Welcome everyone to today's podcast. I'm Joanna, and with me are Matthew, Kimberly, and Justin. Today, we're diving into the world of catalysis science, specifically, benchmarking. It's a topic that might sound a bit technical, but trust me, it's crucial for making real progress in areas like energy and environmental sustainability.
Hey Joanna, great to be here. For those who aren't familiar, benchmarking in catalysis is essentially evaluating a catalyst's performance against a set standard. Think of it like comparing the fuel efficiency of different cars. You need a common test to see which one truly performs better.
Exactly, Matthew. And in catalysis, we're looking at things like activity, selectivity, and how long a catalyst remains effective before it degrades. It's all about creating a level playing field for comparison. So, why is this benchmarking so important, Joanna?
Well, Kimberly, benchmarking enhances reproducibility. In the world of research, that is incredibly important. If one researcher publishes results, another should be able to follow the same steps and achieve similar outcomes. Benchmarking also improves effectiveness by clearly defining the performance standards for catalysts. That pushes scientists to innovate and refine their work.
Right, and it's not just about performance metrics. It's about meticulous documentation and sharing of methods and measurements. If the process isn't written down clearly, it is impossible for scientists to reproduce experimental results. Sharing this data allows us to build on each other's work, and that's where the real breakthroughs happen. In theory, anyway.
Think about it, catalysis research has exploded globally. There's a massive amount of information being generated. Benchmarking helps us manage, share, and utilize all that data more efficiently. It's like creating a universal language for catalysis research. You could almost say that it is critical to accelerating the entire scientific endeavor.
So, can we give some specific examples? How does benchmarking work in different areas of catalysis?
Absolutely. Let's start with computational catalysis. In this field, benchmarking involves comparing different theoretical methods against each other, and, crucially, comparing computational results with experimental data.
Right. Computational work could greatly benefit from common standards and ways to share results, models, and code. Imagine if everyone used a similar language for their calculations. It would be so much easier to validate and build upon each other's findings.
One of the biggest challenges is making sure that these theoretical results align with reality. We need high-quality experimental data from well-characterized materials to validate our computational models.
And what about heterogeneous catalysis? That's where we're dealing with solid catalysts, right?
Exactly, Kimberly. In heterogeneous catalysis, benchmarking typically means comparing a new catalyst against a standard catalyst under consistent reaction conditions. The tricky part is that the best conditions for one catalyst might not be ideal for another.
It's essential to ensure that the data reflects genuine rates and selectivities. We need standard catalytic reactions with agreed-upon rates for well-characterized materials. Think of it like having a set recipe that everyone follows to compare different ingredients.
Deactivation is a huge factor, too. Catalysts don't last forever. You have to quantify how quickly a catalyst loses its effectiveness, whether due to sintering, poisoning, or other factors. There is always some degradation, but benchmarking helps researchers discover why.
And how does benchmarking play out in molecular catalysis?
Molecular catalysts are often seen as well-defined, but reproducibility can still be a major issue. Different labs might get drastically different results, even for supposedly well-established reactions.
Purity of components is critical. You need high-quality analytical data to prove the catalyst or its precursor is what you think it is. And kinetic measurements, understanding how reaction rates change, are super important. What if the catalyst is changing during the reaction, after all?
Selectivity is another key factor. When comparing catalysts, you need to measure selectivity, the ability to produce the desired product, at the same conversion levels to make a fair comparison.
Finally, let's talk about electrocatalysis. That's catalysis happening at an electrode, right?
Precisely. In electrocatalysis, we aim to compare the electrocatalytic activity and selectivity quantitatively. It is very important to normalize to catalyst parameters so that all researchers are on the same page.
Standardized reporting is essential. Each electrocatalysis community should have its own way of detailing activity and selectivity, making sure it is easy to compare different materials for a particular reaction.
Researchers need to provide complete descriptions of their experimental protocols and methodologies, and provide the reader with the highest degree of insight into the work. That includes catalyst concentrations, reactant concentrations, and scan rates. The more, the better, essentially.
It sounds like benchmarking isn't just about comparing catalysts, it's about creating a culture of transparency and collaboration.
Exactly. And it is important to address a problem: reproducibility. There have been some high-profile cases of irreproducible research in other fields, and that is something we want to avoid in Catalysis.
Journals, funding agencies, and institutions need to reward openness and reproducibility, not just novelty. If researchers are incentivized to share data and methods, we'll see a huge improvement in the quality and reliability of research.
There's also a cost concern. It takes time and effort to document and archive data properly. We need to ensure that there are sustainable, open-source infrastructures to support this effort.
So, what's the future of benchmarking in Catalysis?
We're entering a new era, driven by advances in both experimental and theoretical methods. We can now study working catalysts in unprecedented detail. Benchmarking, combined with best practices, will be key to making the most of these opportunities.
And it's not just about individual researchers. We need larger initiatives to create and curate benchmark databases that everyone can contribute to. That's where we'll see the biggest gains.
Essentially, benchmarking fosters fair comparisons of catalyst performance. This, in turn, pushes the field towards developing common standards. Better measurements of catalytic properties make research more transparent and ethical.
To wrap up, remember that reproducibility, thorough documentation, and data sharing are not just good practices, they're essential for accelerating progress in catalysis science. By embracing benchmarking, we can tackle global challenges in energy and environmental sustainability more effectively. Thanks for joining us today, everyone.
Thanks for having us, Joanna.
It was a pleasure.
See you next time.